Welcome to the lesson on section 3.10, Linear Approximations. In this lesson, you'll learn how to use calculus to approximate function values without a calculator. The tangent line intersecting a graph at x equals a can be used as a linear approximation of f at a. Recall from the beginning of this course, we discussed the idea that when you zoom in several times on the point of tangency, the function graph and the tangent line will appear to be nearly the same. By the same principle, as long as we use x values very close to a, using the tangent line to find y when x is a will be pretty close to the actual value of y on the function graph. In example 1, let's find a linear approximation of y equals x plus cosine of x for x is near 0. This is just a fancy way of asking us to find an equation of the tangent line at x equals 0. The derivative of y is 1 minus sine of x. So when x equals 0, the slope of the tangent line is 1 minus sine of 0, which equals 1. Our tangent line intersects the graph at x equals 0 and y equals 0 plus cosine of 0, or the point 0, 1. The line with slope passing through 0, 1, with slope of 1 rather, passing through 0, 1, is y equals x plus 1. I'll use the function name L of x to stand for linear approximation. Suppose we were asked to approximate the value of 0.1 plus cosine of 0.1 without a calculator. I would plug in 0.1 for x in our linear approximation, arriving at 1.1. The actual answer is about 1.095, so we did get pretty close. Here's a graph of y equals x plus cosine of x in blue and the tangent line in red that we just found. You can see how close together the two graphs are near x equals 0. In example 2, consider the function f of x equals x raised to the power 1.857. In part A, a linear approximation at a equals 1 would be the tangent line to f when x equals 1. The derivative is 1.857 times x to the 0.857. So the slope of the tangent line when x equals 1 is 1.857. The point of tangency occurs at 1 f of 1, which is 1. So the line through 1, 1 with slope 1.857 has the equation y minus 1 equals 1.857 times x minus 1. Isolating y, our linear approximation near x equals 1 is 1.857 times x minus 1 plus 1. In part B, we'll use the linear approximation to estimate values of f at 1.1, 1.01, and 1.001. Just plug these values in for x in the linear approximation we just found. Notice that these work out nicely without a calculator if we leave our linear approximation in point-slope form instead of simplifying it first. I can't fit x equals 1.001 on the screen, but if you follow the pattern, you can predict that L of 1.001 will be 1.001857, which is an approximation for 1.001 raised to the 1.857 power. In example 3, we'll use a linear approximation to estimate the value of the square root of 99.8 without a calculator. First, we decide on a function f of x and a point of tangency. This part of the problem will usually have many different options. Narrow the field of choices by choosing a function that is relatively easy to differentiate and an x value that makes it easy for you to evaluate this function. The square root of 99.8 is close to the square root of 100, which is easy for us to evaluate without a calculator. So let's choose the function square root of x and find the tangent line at x equals 100. Next, we'll find an equation of the tangent line at that x value. Find the derivative. Find f prime of 100 for the slope and f of 100 for the point. The tangent line has slope 1/20th and passes through the point 100, 10. Isolate y to write the linear approximation. We would have to plug in 99.8 for x to get the exact value of the square root of 99.8 in the original function f. So that means we'll plug 99.8 for x in the linear approximation to get our estimate. Using our linear approximation, the square root of 99.8 is about 9.99. This concludes the lesson on section 3.10, linear approximations.